In this tutorial, we will be creating a parametric bench in BeeGraphy entirely through Typescript, with Claude helping write and refine the logic behind the geometry. This tutorial walks through how to script the bench from scratch, build its structure through curves and solids, and control the overall form through code rather than manual modeling. You will see how BeeGraphy's geometry classes and solid tools can be combined with Claude's code generation to create a fully parametric, customizable bench that updates instantly whenever the script changes. Before we begin, let's first see what Typescript is. Typescript refers to the Typescript node inside the BeeGraphy editor. It is not a special language variant. It is simply standard Typescript code used to generate parametric geometry inside BeeGraphy. Now, using Typescript in BeeGraphy might seem odd at first because the platform is visual. But visual nodes have limits. They are great for quick ideas and spatial layouts, but they struggle when you need loops, repeated patterns, or logic. Visual nodes are great for quick ideas and smaller projects, but as designs get more complex, the graph can get messy. You end up repeating the same node clusters, building long chains to fake loops or conditions, and constantly fixing multiple places whenever something changes. That slows you down. The Typescript node solves this by letting you handle the complicated parts with clean, simple code. You write the logic once instead of duplicating it. You generate repeated elements programmatically, and you express variations with easy conditions. This keeps your graph clean, easier to understand, and much easier to update. So Typescript does not replace visual nodes. It supports them and gives you extra control when your ideas get big. Let's explore what Claude AI contributes to this project. Claude AI can make working with BeeGraphy's Typescript node much easier and faster, especially if you are not fully comfortable writing code from scratch. Instead of figuring out every line yourself, you can simply describe the shape, pattern, logic, or behavior you want, and Claude will generate Typescript that follows BeeGraphy's structure and classes. This is helpful because BeeGraphy has its own way of handling points, curves, solids, loops, and conditions. Claude understands these patterns and can produce code that fits the Typescript node without breaking. Claude is also useful when you need step-by-step guidance. You can ask it to first set up the basic function, then add inputs, then build a loop, or create conditions for variations in your design. This makes complex ideas easier to break down and implement. If you already have a script but it is not working, you can paste it into Claude and ask for debugging, cleanup, or optimization. It can explain what each part does, so you learn as you go. Overall, Claude works like a coding partner. You focus on the visual idea, and Claude helps turn that idea into clean, functional Typescript that keeps your BeeGraphy graph simple and efficient. Now we will start prompting. In this case, we asked Claude to make a rectangle by giving it two additional things: the BeeGraphy guide links and a sample code. Links to these resources can be found in the description along with our blog exploring the scope and application of scripting in detail. Providing both of these things is important in order to make Claude aware of the BeeGraphy classes and the sample code structure. We will go step by step, starting with a simple rectangle, making arrays, manipulating the shape, and texturing. Let's begin this tutorial. Enter the doc links and the sample code and write a prompt to make a simple rectangle. Copy the code. Open the BeeGraphy editor, add a Typescript node, click Edit, and in the script window, paste the code we copied. Click on Ports. Delete the default ports. Copy the output name from the bottom of the code. Paste it on the out port. Copy the import names from the code. Paste it in the name and label section of imports. Do the same for all the ports. Connect the number inputs. Type error appears when the ports are incomplete or their type is incorrect. If it's correct, refresh the page and that will resolve it. Now we have our rectangle. In the next step, write a prompt to make a raise of the rectangle we created. Add the new ports and number inputs. Type error wasn't resolved by refreshing the page because the out port name was incorrect. Now, we will enter the prompt to make inward curves on the sides. Paste the code. Add the new ports and number inputs. Now we have the slabs. Now we will resize the bottom face. Adding color to the geometry. The geometry got altered, so we will try prompting again. Altering the concave cavity. Our model is complete. This is a guide of all the errors you might encounter while building your own geometry and how to resolve them using Claude code. The design industry is shifting toward the use of parametric, generative, and adaptive systems throughout architecture, furniture, products, and interfaces. Being able to think and work in a parametric way is becoming a crucial skill. BeeGraphy offers a space where designers can begin this journey without being overwhelmed. The Typescript node does not intend to make this platform more complex. Instead, it empowers those designers needing more. It supports a smooth transition from visual to structural logic. It builds confidence in designers to take on bigger and even more complex projects. It actually prepares them for workflows practiced in professional computational design studios. Merging nodes, TypeScript, and AI assistants reflect how many real-world design teams are used to working. It reflects an understanding that creativity does not come from tools in isolation, but from how well you use them together.